The cutting force and thrust components are in an orthogonal cutting operation are found to be 800 Newton and 600 Newton respectively. The width of cut is 4 mm, the depth of cut is 0.5 mm and chip thickness is 1.2 mm. Assuming the rake angle to be 0 degrees, the specific cutting energy will be. Here, the specific cutting energy is nothing but the cutting energy required per unit volume removal rate of the material. So that here the specific cutting energy, let us say u suffix c is equal to the cutting energy required is cutting force into velocity and per unit volume, that is thickness of the chip and width of the chip and velocity. So which gives uc is equal to fc by t naught b naught, that is t naught and b naught are thickness and width of the chip is equal to 800 by 4 into 0.5 is equal to 400 Newton per mm square. So in the option, the right option is C. Match list 1 with list 2. Here list 1 consists different types of instruments and list 2 consists principle of inspection. Here in list 1 the instruments are dial indicator, pneumatic gauge, go or no go gauge, and here the principle of inspection is non-contact, limit of size, comparator. Here go and no go gauge related with the limit of size. So go gauge use it to measure the highest limit of the instrument and no go gauge is used to measure the lowest measurement of the instrument. And here pneumatic gauge is a non-contact type gauge and dial indicator is comparator. So in the given options, the right option is B. B is the right answer. Match list 1 with list 2. Here list 1 consists different types of process and list 2 consists mold making technique. So in list 1 green sand molding, shell molding, investment molding, ceramic molding, and making techniques are pouring, dipping, compaction and resin bonding. Here green sand molding for the process mold making technique is pouring. So here P matches with the first one, and here Q shell molding, the mold making technique is compaction, and for investment molding shell making technique dipping, and for ceramic molding resin bonding. So in the options, the right option is C. C is the right answer. List 1 with list 2. So here some machining process are given and some related terms are given in list 1. So here P machining of conductive material can be done by using EDM. So that P matches with 2, and ruby rod used in LBM. So that here Q4, and electrolyte used in ECM. So it is R related with 1, and here abrasive slurry is used in ESM, ultrasonic machining. So S3. So in the option, the right option is C. The minimum carbon percentage required in steel so that it may respond to hardening by heat treatment is the right answer is 0.02%. In the figure, ABCD is a 4-bar mechanism. At the instance shown, AB and CD are vertical and BC is horizontal. AB is shorter than CD by 30 centimeters. AB is rotating at 5 radians per second and CD is rotating at 2 radians per second. Then the length of AB is. Here both AB and CD are vertical and BC is horizontal, so that the linear velocity of B and C are equal. So that from that equation, here omega AB into AB is equal to omega CD into CD. So here AB is rotating at 5 radians per second, and let us say AB and omega CD, that is CD is rotating at 2 radians per second, and here AB is shorter than CD by 30 centimeters. That means CD is equal to AB plus 30 centimeters. So from this equation we can get the length of AB. So here AB is equal to 20 centimeters. From this equation, AB equal to 20 centimeters. In the option, the right option is B. In the statement, an eccentric mass rotating at 300 rpm will create x times more unbalanced force than 50% of the same mass rotating at 300 rpm, then x stands for. So here unbalanced force is given by So unbalanced force, let us say F is equal to W by G into K into the speed of the rotating speed, that is 300. Sorry, 3000. Sorry, it is 3000 RPM. So K into 3000. When uh, it creates X times more unbalanced force than the 50% of the same mass rotating at 300 RPM. So when 50% of the mass rotating at 300 RPM, then unbalanced force is equal to some W by 2 by G into K into 300. So here, let us say this is F1 and this is F2. Here F1 is equal to X times F2. So from these two equations we can get X value, that is equal to 200. So in the option, the right option is D. A shaft has an attached disc at the center of its length. The disc has its center of gravity located at a distance of 2 mm from the axis of the shaft. When the shaft is allowed to vibrate in its natural bow-shaped mode, it has a frequency of vibration of 10 radians per second. When the shaft is rotated at 300 revolutions per minute, it will whirl with a radius of. So here, the whirl radius is given by E by omega 1 minus omega 1 by omega 2 whole square minus 1, where E is the eccentricity of the center of gravity. So here the center of gravity located at a distance of 2 mm from the axis of the shaft, so that it is 2 mm, and here omega 1 is given by 10 radians per second, and omega 2 is the shaft is rotated 300 revolutions per minute, so that omega is equal to 2 pi n by 60. So from this equation it is 2 pi into 300 by 60. So it is equal to 10 pi. So it is 10 pi whole square minus 1. So from this equation, so y value is given by 2.25 mm nearly. So in the option, the right option is B. So here it is minus 2.25, but here we need just radius of the whirl radius, so that it is 2.25 mm. If two links are connected at a pin joint of diameter 60 mm having angular velocities 18.85 radians per second and 3.4 radians per second respectively, the rubbing velocity at the pin joint when both links rotating in different directions is. So here the rubbing velocity is given by the radius of the links, the radius of the pin joint into omega 1 minus omega 2. So here the pin joint diameter 60 mm, so that the radius of pin joint is 60 by 2, and omega 1 is 18.85 radians per second and 3.4 radians per second. Omega 2 is 3.4 radians per second. So here, but these two are rotating in opposite direction, so that one is plus and another one is minus. So here minus 3.5. From this equation, it is equal to 67.5 mm per second, and is equal to 0.667 meter per second, and in the option, the right option is C.